Welcome friends, welcome to the lecture series of analog electronics. Today we are going to learn about the differential amplifier with two op-amps. That is nothing but a two-stage instrumentation amplifier also. So that is the concept. So in this lecture we are going to discuss this circuit, that how it will be working. So here you can see there is one diagram. We have used only two op-amps, and what it will do, it will be amplifying the difference between these outputs, that is our V3 and the particular signal V1. So that concept is known as the instrumentation amplifier, or we can say the differential amplifier also. The differential amplifier is working as on principle of the two inputs. If we apply the two inputs, and whatever the difference between these two inputs will be amplified at the output terminals. So from that concept, let's understand that if we are finding the voltage gain at the particular first stage, this is our first stage. Here you are seeing that is our first stage. So taking the A1, we will call this particular amplifier as an A1. A1 is a non-inverting amplifier. So from this concept we know that AV1, we will call the voltage gain as an AV1. It is our RF upon R1 from the non-inverting instrumentation amplifier. Now here you can see that, but R3 is nothing but the R1. This both the values will be same. So we are taking that R3 as an R1, and R2, that is our R2 over here, is nothing but our RF. So putting these things into the equation, we will get this AV1 equals to 1 plus R1 divided by RF. And if we notice this thing at the V3 terminal, that what happening at the V3 terminal, then it is like V3 is equals to AV1 into the V2 equals to what happened, that R1 divided by RF, this one is R1 divided by RF multiplied by the V2 terminal. So that will be our V3 term achieved over there. Now for the output stage, what we will do, so here we are taking at the output stage. For the output stage, let's see, that second stage is the difference amplifier, that we know that it is differentiating the difference between these two terminals. So its output voltage is obtained by using the superposition theorem. So from the superposition theorem, what we are doing, that is VO is equals to VO due to V12 alone. From the superposition theorem, this term can be written that VO is due to the V12. Here we can see that V12 is nothing but the difference between this amplifier, that is V1 minus V2, and plus the second term, that is VO due to V3 alone. How much the amplification will be given by this V3 amplifier, that is our V3 alone. So substituting this all terms, 1 plus R1 divided by RF multiplied by V1 minus RF divided by R1 multiplied by V3. So that is the thing which can be easily can be understood from this circuit diagram, and substituting these terms in the expression of substituting the term in the expression for V3. So what is there? Then we can write that VO is equals to 1 plus RF upon R1 multiplied by V1 into RF upon R1 into 1 plus R1 by RF multiplied by V2. So what we have did that we have just put it the equation that we get over here V3 as in the place of the V3. So after this further, if we can simplify this equation, so what does it will tell? Let's see that 1 plus, so 1 plus RF by R1 into V1 into RF by R1 V2 minus V2, that is 1 V2. Here we can see write this. So what we have did in this, that you have seen that we have applied this RF by R1 and multiplied with these terms. After that, further simplification, RF by R1 multiplied by V1 minus 1 plus RF upon R1 into V2. We have taken the each term apart with the V1 and with the V2, and from that equation after that 1 plus RF by R1, if we take this common, then V1 minus V2 can be written. So that is the thing, that output voltage can be achieved by this equation, and whatever the gain of this circuit will be like this, that is 1 plus RF upon R1. So that's all for the differential amplifier with 2 op amps, or we can say the 2-stage instrumentation amplifier. So I hope all of you may get this particular how it can be done, and how this term can be mathematically expressed. Thank you.